I want to start this off by kind of setting ground rules. We can have nice things. We're going to start talking about performance and just building web apps that are fast and fun. And I think when people say you need to make this web app fast and performant, they instantly cut out all the fun things and all the things that make your app unique, stand out, things that make the app feel enjoyable. Because who wants to use a boring app? No? No one wants to use a boring app? Good. So we're going to be talking about delighting your users with performant apps. My name is Mike Hartington, Director of DevRel at a company called Ionic. You can find me on Twitter at mhartington, real original handle. I will mostly tweet photos of my cats and my dogs. So if you want to see any of that, you should follow me there. Okay, so let's define performance, because performance as a term can be a loaded topic. If you've heard things like first meaningful paint, first impactful paint, largest cumulative layout shift, these very obscure acronyms for obscure things that may happen when you load a web app. These are all great. These are things that you should be concerned about, but these are things that I think exist outside of your responsibility, definitely exist outside of my responsibility, because that I would hope that the tools I use address that to begin with. They put me on the happy path to having a successful app, and they take care of all of the loading speeds, the parsing times, they take care of all of the smaller details that I shouldn't have to do. So that goes for Angular, React, Vue, goes for all the tools out there. We're talking about UI and UX features. Because once the app loads, there's still plenty of opportunity for you to destroy the performance and make your app super slow. If you're doing anything with animations, that's almost like an instant, oh no, I tried to do this thing and then my app started shuddering a little bit and it brought everything down to a halt. Doing any kind of state changes or UI changes based on things that happen inside of your app. Instant performance bottleneck right there. And then if you're trying to do some expensive computation, that's going to be a big bottleneck. The fun thing about single-threaded JavaScript is that if you try to do any math, that's going to be blocking. We're going to see how we can work around that. So these are the things that you think about and put all this time and effort to making sure your app loads and it passes Lighthouse, but none of the actual interactions feel fast or great. And this stuff is hard. Be fair, it's not easy to do this, but it leads people to this weird, it doesn't feel native. Now, maybe this is just because I work in tools that try to do cross-platform stuff, but this, it doesn't feel native, is like a key indicator that native apps have trained a generation of users what to expect. You're going to look at Twitter. People are going to think, oh, it's just so fast and smooth. Why can't my internal app be this fast and smooth? We're doing the same thing, displaying images and random JSON data. Now, native has kind of got a little bit of a head start here because they've had 10 years of all these features being built into their platform and into their tools and their SDKs. So animations from native, whatever it is that they do, instantly become performant and fast because of the underlying implementations. The web, we don't really have that. We have web animations, but you can still create a terrible experience with that. Now, I don't know about all of you. This is my favorite app. Some folks love Spotify. That's cool. It's whatever. There's sponsors out there. Say hi to them. But I love Apple Music. It is a unique app. It's what I would consider a perfect example of something that goes beyond Hello World, because there are not many unique screens here. It's fairly small in scope. It's just showing data in a bunch of different ways. But what they've done is add a bunch of features here that make the app feel more unique than your standard music player. We'll wait for the video to loop. I had it all timed out. Come on. There we go. Okay, so we not only start off by playing some music, we can play and pause, toggle the song, and then the album artwork is going to shrink and scale. We can go to the next song, and then the background is going to reflect the current playing song in their album art. We can have some UI changes that are super smooth and fast without having to even think about it. It just appears, and we're happy. So I don't know about anyone else. I've had 2.5 years of free time, and I was able to try to rebuild Apple Music with the web. And I broke down the 3 things that I highlighted in that video into being able to do performant animations, handling dynamic UI changes and dynamic animations, and doing some of that reactive background changes to reflect new album art. And this is what we're going to be looking at. For context, I did use Ionic and I used a framework called Angular. None of these principles matter. You can use Tailwind in React. You could use Bootstrap in Vue. You could use Svelte in some other UI library. The principles do not get tied to the tools. Apply this to any place inside of your app, no matter what you're using. I just happen to use what I was most comfortable with, and I think I was pretty successful. So, starting off with animating the right things. This is that elevation trick that they were doing with their cards. Creating that sense of elevation as believable and smooth. So, just for reference, to make sure we know what it is again, as you play and pause, the card or the album artwork feels like it's moving closer to the surface. There's a box shadow under there or some kind of drop shadow that is intensifying as the artwork kind of floats. And as they get closer to the surface, we should lessen that box shadow. Fairly simple stuff. I can open up Figma, RIP, and be able to have that implemented without any problems. And I did the first thing that someone else would think. Go to Material, copy some CSS from their docs, and ship it, right? You can copy code from the internet, and nothing's going to go wrong ever. And this is no joke. Material actually does have really good docs on this. They have a whole section on elevation, which you don't ever see that from any UI library. And they show you when you should use certain elevations, what styles you should use. It's actually legit good. We're going to see, though, why it's also legit terrible. I copied some CSS, and I want to stress test this. So I added a little keyframe animation, and I'm just animating between 2 shadow values here. Now, you can't see it that well because, in hindsight, I recorded this with a dark drop shadow. Let's move over. In a little bit, we'll see it a little bit more clearer. So this seems like it's going to be good, right? Totally fine if you can tell that there's a shadow there. Shadows are terrible for your performance. If you have any linting rules, figure out where you can add a lint rule that says no box shadows or drop shadows in your CSS, and your performance will just skyrocket. Shadows have a really unique feature in that as the browser tries to interpret them, it'll say, okay, at this point, there's a shadow. It has some arbitrary RGB value. I need to calculate the background color that gets overlaid with that. That 1 pixel is perfect. Goes to the next pixel, and next, and the next. And it does some operations to optimize this, but every time that you have a shadow, there's what's called a repaint cycle. And that is very expensive. Might not seem as expensive on your fancy MacBooks or your desktops, but on a couple-year-old phones, you'll see a CPU usage skyrocket because it's having to calculate that. And that's a static shadow. If you add an animation in there, it just gets worse and worse and worse. And you can actually see this in the browser. There's this really cool feature called paint flashing. So everything in here is basically being repainted as that shadow is animating. So even little parts down here that aren't necessarily impacted by that shadow are getting repainted because of just how the browser works. So let's go to Chrome real quick, and I promise this should appear a little bit better. There. So that's the box shadow animation that was originally used. Doesn't look terrible. You don't think it would be bad. Let's open up DevTools. So DevTools has this really cool feature. You can go to rendering, and if you don't see it, you just click this little plus button over here and you'll get it. And then they have this paint flashing option down here. And that is where we're going to see all the impacted areas inside of our app. Now, this is, again, smaller use case. I'm on my desktop. It's not really going to be that impactful. Let's go ahead and emulate a terrible 4-year-old device, probably running some old version of Android. Let's go with a 6x slowdown because CPU usage is pretty comparable to that. And let's go to performance monitoring. I'm going to zoom in just a little bit. We're going to see how this goes. Let it run for a bit. So we're hitting about 30% CPU usage. It fluctuates a little bit here and there. And we have something like 60 style recalculations and repaints happening inside of our app. 60 times per second, which normally you want 60 frames per second, but in this case, this is terrible. This is, again, emulation is not going to be a perfect way to emulate or see how the impact of this could be on a smaller mobile device, but this is a good indication that we are doing something bad. We should be fixing this. So, again, just in case that was going to work, this is the code that we use for this. Quick little keyframe animation. We just change the values of the box shadow as we get to different steps. So that'll create the illusion of growth. What is a box shadow really, though? It's just a layer. It's just a layer. If you think Photoshop, again, RIP Figma, you have something that just sits underneath your main element. You set the color, you set the blur, you set the spread and size, and you realize that you could rebuild a box shadow without using box shadow CSS. You could use something like a pseudo element. That pseudo element is going to give you 90% of the same effect, but it's going to be far less impactful to your performance, and we can prove this. So we will just come over here and comment out this code. And like a good developer, I have everything prepared ahead of time. And we're just going to save and go back to this demo. So there's our shadow. It's growing. This is using the pseudo element. And we're going to go to rendering, keep that paint flashing enabled, performance monitoring. Or let's go to the performance tab first just to make sure we are still doing our throttling. And then we'll just watch these numbers come in for a little bit. There we go. Maybe that's going to be a little bit clearer. So we're still doing our animation. I have the paint flashing flag enabled. I'm not painting anything as this is happening. It's a small change, but we are getting something that feels pretty similar. It might not be as complex of a box shadow, but 5% CPU, 0.5% CPU usage, no style recalculations, that's an instant win. And we can go ahead and take this a step further by taking all of the previous box shadow code and just moving this over to use multiple elements. So if you're working with custom components or something in that nature, you could just have shadow 1, 2, 3, and adjust the layout of it so that way, because light is not just a natural thing, there's different spreads on each of the light, and all of those are just divs. Glorified, nothing meaningful parts of your component. And again, with that all together, performance is super good. We are happy. Our app runs smooth. And if you are working inside of a system that has shadows all over the place, here's an instant win to just beef up your performance. Your users are going to be happy for it, and they probably aren't even going to notice that the shadow may be slightly different. but it works. So we can animate the right things by knowing that we should not animate box shadows. Again, CSS lint rule, that would be great to have. Ban box shadows, that'd be perfect. But when we do need to animate stuff like that, we think about how can we do it in an approach that is going to get us similar results, but slightly different. Moving on to our next part, we want to handle that cool layout change as you open up the queue of songs inside the music player. This was one that actually almost broke me because I thought this was not going to be possible. I had like a big existential crisis about this. And I'm not joking about that. It was actually super difficult to do because I could animate that main section very easily. It's when you start to add the second thing, then all your defined values for CSS are completely thrown out the window. You can't do it with just layout changes, applying a class. You now actually need to have some animation to figure out what are you doing here. I almost gave up on this and I was just going to do like simple fades, thinking that was going to be the compromise I'd have to make, until some Googling and some very smart people said, just use flip. And if you don't know what flip is, it is an acronym because we as developers love acronyms. It's this concept where you figure out the animations backwards. So what we do is we have this snapshot of our element in some place at some point in time. It is basically, hey, I am left this many values, top down this many values, x and y, width and height. All of that is just inside a little snapshot. Then we cause a layout change, apply some classes, change the DOM around, what have you. And then you get a second snapshot of what that element is. Same x and y, width and height. Now, you have the two values. You do some math, invert them, do some division, subtraction, comparison. You have free range here to figure out what the difference is. But most of the time, you're doing subtractions to figure out the from to value. And then once you have that, you play an animation, and it simulates as though that element just moved over without you even realizing it, even though for a split second, it was already in the place it needed to be. And this is the code that does that. We're going to take a look at it. This is a very short initial pass version, and then we're going to look at the real version for it because it gets pretty hairy. We have these two elements here. They are that main player section and then a queue element of songs. We'll go ahead and we'll call this getRec function. Fun story about the getRec function. It's actually just a way to not type out get client bounding rec, because that is a very, very mouthful of a function, and it's very difficult to type. So I want to just say, I'm going to type it once, and I'm going to have get rec. And it also kind of makes me laugh because it's like, just get rec. So we get our position. We know the x and y of each one. Let's cause a layout shift. We are going to completely change the layout. We are going to bring the queue all into the viewport. We're going to move the track player over to the left, and it's going to work. Now we get those positions again. Now here we have a very simple approach to this, where all we're doing is just getting the left and right difference, and we're going to move that over. We could have some more complex stuff here, where instead of doing math to figure out, we're just going to do some comparison. So we're going to get the before and after heights, and if it's 0, we're going to animate from 0.8 to 1, and if it's greater than 0, we're going to animate from 1 to 0.8 to create an illusion that it's kind of growing and appearing out of nowhere. We'll queue up that animation. This is using an animation function internal to Ionic, but like I said before, it's not going to limit you. You do not need to use Ionic for this. It's just a little helper thing. We'll create an animation, animate the element, and we'll set up some animations that we're going to do. This one, transform, again, 0.8 to 1 or 1 to 0.8. And then we have this opacity change from either 0 to 1 or 1 to 0. We have this concept of a parent animation chain where we'll just push that up onto the topmost animation queue, and we're done with it. Now the track player is a little bit different. We're just animating it left to right. We can do some before styles to make sure that we are animating from the correct point inside of the DOM. And then we can just push that onto the chain as well, and we're done. What does that get us? This. Now, you're going to see it does just disappear on the outgoing animation. I'll show you how we fix that. But for the most part, this animation is working, and I don't know where these values are going to be. I don't really care. I know that I just need to do some diffing to figure out here's the before, here's the after. And because this is all JavaScript, we can be a little bit fancy. We can get some match media queries in there to say, okay, well, this is what we're going to do if we're in landscape mode. If we're in portrait, we can have a completely different animation that feels right to that layout. Now, please do not judge the animation that we're going to look at because it can be pretty complex. This is 266 lines of animation code. You can see we have some comparisons to look at the opacity difference, the vectors for, are we going from 0.5 to 1 or what have you. All that is just pretty nice. Get rec, famous little function. All that is pretty good. We'll see the animation chain, the is portrait, and then we're going to start that animation. So here, if we are not in portrait, we're going to get the player queue. We're going to get some layout changes. All this should seem pretty familiar from the slides. We do some extra work here to figure out if this is the opening animation. Like if we are showing it for the first time, we now need to deal with my favorite thing, which is absolute positioned elements, and figuring out how are we going to animate them back and forth. So we do some comparisons here. We're just creating some objects to know where those positions should be. And then we come down to our before styles, and we set those positions in space at that time. So this is literally just whatever, removing it from the general flow of the DOM. We're just going to put this here, and we're going to animate it left and right. Then we do the transforms, and then we clear all of that absolute positioning after the animation has been done. Pretty same for the now playing element. And then for the portrait one, we're just doing the same principles for different elements. We're grabbing the thumbnail image, we're grabbing the title, we're grabbing the player queue again, and we're just animating them in different parts. So once you have the initial concept, it's really just about finding what values do you need and trial and error. I will say that the in Chrome, or in this case in Edge, the animation tools down here are super helpful because you can just set it to be, let's go for a 10x slowdown, and we're going to watch that over time. I'm going to close this because my laptop sounds like it's ready to take off. So you can use the animation cues to kind of figure out where things are. It's like, okay, is this right? Adjust, and then ship it. Like I said, I was using Ionic's animation API. You do not need to use Ionic to do this. You can use pure web animations, and it's going to be pretty similar approach. There is a flip animation plugin for GreenSock. So if you are using GreenSock in your organization and you want flip animations, it's literally a one-liner to add it to your project, and then you have access to being able to include all those animations. And they even have like this, let's go off script a little bit. Flip. Come on. Yeah, here's like the whole breakdown for everything. And then they have the whole demo. They used to have a demo. And this is what happens when we go off script. Okay, that's not really that great of a demo. Thank you for failing me, GreenSock. We will move on. I promise you, though, that the library is actually really good, and you should be using it if you want, or just write it yourself. There's various implementations too, but it's important to know that it is all just JavaScript. So we can animate things in the background, handle that dynamic unknown situation. Layout changes are working super fast. What about that last part, where we're able to have a background color change as the music plays? Just for context, to make sure that we're all on the same page, this is just a very subtle effect, but it is one that stands out and I think is the most compelling part of Apple Music. Regardless of their music model and the subscriptions, I'd just be happy to have this. And I kind of cheated because I have done this before. We're basically extracting colors from images, which surprisingly, when you do this, your colors are always going to be a touch more like brown in hue for whatever reason. I don't know why, but I did find a great library that was helping me do this. And I kind of updated it, made it to TypeScript, and I want to make it faster because it all ran on the main thread. If you know anything about single-threaded performance, if you try to do a bunch of comparisons of a giant image, it's going to slow it down. So we need to figure out how we can make this faster. Library in question I used was Color Thief. It's been around for a little while. It's a super cool library. I don't think really many people know about it, I would hope. More would, but you give it an image, you call a function on it. It will not only return the dominant color, but it will return a palette of colors that you can set to limit. And then it'll also return different values for how accurate you want. So the quality of sampling in here can be adjusted so that way, oh, we're going to just sample this 50 by 50 square of pixels versus every single pixel in that. I made it faster by using web workers. Has anyone used a web worker before? You? Okay. They're pretty cool. They're not as magical as you may think. And then this concept in Angular of having a directive means I just get to attach it to my image, and whenever that image source changes, I pass that data to the web worker. So this is the component that's being used here. We have this first thing where we're reacting to changes on the source property or attribute, however you want to call it. If the image is like the default image, you really shouldn't do anything. And if it's the first change, we're going to just get right to it and extract the colors. There are some quirks to the Apple Music API in that they return multiple values for the image, even if it doesn't change, but just with different query params at the end. And so I had to do this really stupid thing of like getting the image values and just saying, is this the same image with different parameters? If so, don't do extra work, just no opt-out afterwards. But if it's an actual image that's different, then go ahead and process it. We then call this get palette from URL. All this does really is download an image and save it to JavaScript in memory. And then we have this get palette function, which will create a canvas. We put that image in the canvas, and then we pass all of the image data to the worker. So we're just passing in the number of pixels, the pixel length, the actual pixel itself, the pixel length, the color count, how many colors should we be returning, and then the quality for the sampling. Once that data has been processed inside of the worker, we can just react to that where we have data coming in. We can emit an event. In this case, that's how I did it, but you could also just work with the component directly and change something. Now, the worker for this is actually just a straight up copy paste of Color Thief. We are doing so many comparisons and a lot more math than I feel comfortable explaining because I don't know 100% what's going on in here. I know it works. And I think that's good enough. But all of that is just to quantize and compare the colors in there. What we have here is the event for when the data gets passed in. What we do here is we just create a multi-dimensional array of all the colors, RGB and A, and then we are passing that to that quantize function. And then once we get the colors back from that, we just do post message, and that's where it gets picked up back inside of our directive. So all of this is just done off thread, not necessarily impacting the performance of our app, but doing some complex stuff. So most people like to show off like doing the Fibonacci sequence. This I think is a little bit more useful. And all that together gets us this. Now this is the web app. As we go ahead and we are going to the next song, the colors instantly change. We're getting that event. And all we're doing is just listening for the event, setting some CSS there, and we have a simple little animation to just fade that color change. Really simple, really primitive, but super cool. So this app is actually up on online right now. You can scan the QR code. You could go to startrack.ng or /ng.web.app. It provides all of those features, does everything, and then more. Because I've had some time since then to really make it better, I think. And we're going to look at it. I just loved having every opportunity to show it off because I'm super proud of it. But what we have here is the app. Nothing really overly fancy. Let's go to search. We're just going to go to something I know is going to have a lot of colorful art. Not that one. That one's lame. We'll go for the official one. Lo-fi hip hop girl. And we're just going to play some music. So we've pushed this a little bit further. We now have play and pause working. We are still using those shadows. They're a little bit more subtle, and they're actually more noticeable now with a different color background. You can see it very gently down there, and it works. We can open up the layout queue, and notice now we're handling the disappearing of everything, and it fades out simply. So go to the smaller screen. How do we have the layout happening here? Feels right. It's animating up from the bottom, mimics how iOS does it. And then let's go to the next song. We are fading and doing some complex color fades, all to just mimic the album artwork that's happening here. I could keep doing this, keep letting it play, and knowing the kind of music, it's super soothing, so I'm not going to let people fall asleep. We're almost done, I promise. So that's everything put together. The example's out in a while. It's up on GitHub. Check it out. But remember that thing I started off saying. We can have nice things. We can have super awesome apps that are fast and hit all those meaningful metrics through like Lighthouse or other performance measurements. But we can also have UI interactions that are super smooth, feel unique, and feel like something that makes our app stand out, and is just enjoyable to use. Use flip animations for handling unknown and dynamic layout changes. Consider maybe never using drop shadows or box shadows. Again, please someone make a CSS lint rule to like ban box shadows, because half the questions I have to deal with are box shadows. And web workers, try them out. You don't have access to the DOM, but you do have access to all the rest of JavaScript, and there are some things that you can do in there that are going to be super impactful over your entire organization. So thank you so much. If you have any questions, happy to take them, but you can find me outside in the hallway or at the booth. And again, follow me on Twitter. Thank you. Were there any questions? Yes. There we go. Yes.
Do you have any parts of this speech sort of like documented or written as an article or a recording of a presentation like this live anywhere? Because I followed along really well for the drop shadow replacement with the pseudo elements, but my eyes glossed over a little for the flip and stuff, and I'd like to study the code but kind of have some view.
So I can do one better. You can go to github.com, Hartington, Star Trek NG, and that is the entire app up there on GitHub. Zoom in on that.
I'm a little green, so sometimes I have to really go line by line. I'm like, this is what it's doing.
Well, fun fact, this is all being recorded. So in a couple weeks' time, you'll have the video, and I think the conference will put some email out for you. Cool. Any other questions? All right. Go enjoy the rest of the conference, everyone.